Right, so for certain people, I think I need to clear up something about this idea of air pressure on Venus. And I'm using Venus as an example. It's actually quite a good example and a good case in point to be using in arguments about climate change anyway, for various reasons. But just to focus on this issue of the surface pressure of Venus, the pressure on the surface of Venus is about 92 times that on Earth, right? The temperature on Venus is also a great deal higher than that on Earth. It doesn't, however, therefore mean anything quite as trite as saying that the mass of Venus's atmosphere is 93 times that of Earth's. Venus is slightly less massive as a planet than Earth. It's slightly smaller than Earth is. It has a magnetic field, but it's slightly weaker than Earth's. Therefore, it has no other means of sustaining an atmosphere that's 93 times more massive than that of Earth. This is what mass is versus weight. Mass is merely a measure of how many particles something has. What its value is in terms, I suppose, firstly of atoms, but the constituents really of atoms are protons, neutrons, and electrons. Okay, so the weight of something is a measure of how much gravitational force is being exerted over something. But as we know, in the case of Venus, of course, it's not just gravity pushing on something. What it is, to some extent, right, it's gravity pulling all those carbon dioxide molecules down towards the surface of the planet, and there's other things which are also sort of beside the point, actually, like sulfur dioxide crystals and things and droplets in the air in the atmosphere of Venus. It rains sulfur dioxide. But yeah, the huge temperatures from the enormous number of active volcanoes on Venus's surface heat it up to far greater temperatures than we have on Earth. So Earth's average temperature is nominally, by the way, about 18 degrees centigrade, but I don't even believe that, frankly, for a variety of reasons. I think that might be the average daytime temperature on Earth, which, again, muddies the waters when it comes to these sorts of calculations. Yeah, and the highest, by the way, temperature recording of Venus is 467 degrees centigrade or so. I think that's more likely to be the temperature at the equator of Venus than it is at the poles. And I think, like actually with the temperature on Earth, they've got pretty slipshod bad estimates for it. However, if you go up through Venus's atmosphere to about 50 kilometers above its surface, then those huge temperatures, those begin giving way to temperatures that are much more Earth-like, and likewise, the atmospheric pressure drops to about 1 atmosphere or so once you get above 30 miles or so, I think it is. I can't interchange kilometers and miles in my head, and yeah, I've been having to do things like converting things to Kelvin to try and get an even better measure of it. But like, by no means does any of that imply that in terms of molecular weight or in terms of content of subatomic particles or content of atoms, it by no means implies that Venus's atmosphere is 93 times as massive as that of Earth's. So, of course, like things in space, astronauts on the International Space Station, those have no weight. Those still do have mass, though. They're still constituted of particles, right? And mass is the measure of how much matter is in something, how many particles something has, what its fermionic content is, or whatever you like to say about that. Weight is an effect produced usually mostly by gravity, but in addition to the gravity on Venus, there's also this huge amount of temperature, which again we know via the ideal gas law increases the pressure on objects. We know that heated gases exert more pressure on something. So you've got, in addition to the force of gravity pulling things down, you've also got this huge amount of temperature exciting all these CO2 molecules. Those are all bouncing around really energetically in the atmosphere. Gravity's pulling all that down again. So they're constantly trying to force more space between each molecule, gravity pulls it down. Therefore, you get incredible pressures on the surface of Venus. Okay, so but yeah, I mean, interestingly enough, this is also yet more evidence against the greenhouse effect. This example of Venus, because yeah, at 30 miles above its surface or so, there's actually still quite a lot of carbon dioxide up there. Still, that the atmosphere is still quite carbon dioxide rich. It gives way at some point to, I think, sulfur dioxide clouds and things like that, which will also be blocking a fair amount of incoming solar radiation, most likely in the visible end of the spectrum. But yeah, like for a planet that's twice as close to the sun as Earth is, really no part of its atmosphere by rights ought to exhibit Earth-like temperatures, and yet it does, and yet it seems to. And the reason for that is like, well, it's nothing actually to do with its atmospheric constituents. It's nothing really to do with its greenhouse effect. In a roundabout way, it is to do with its proximity to the sun, because it is still receiving a huge amount of solar radiation compared to us. But rather than actually being trapped by the atmosphere, which is fairly negligible anyway, in terms of its heat trapping ability, or compared to the entire planet itself, like all the heat really is just being stored in the mantle, inner core, and so on, and crust of Venus. The tectonic plates on Venus fused, I think, some number of hundreds of millions of years ago, and all tectonic activity has ceased. So this heat has nowhere else to escape to other than through pores on its surface, which create these sort of domed volcanoes. These sort of like flat pancakes, sort of oozing magma, and spewing out carbon dioxide and rain sulfur dioxide, and yet via the heat generated from that. Right, so obviously in a roundabout way, all these temperatures on Venus, they're still caused by its proximity to the sun. Like any amount of temperature change on Earth, I of course believe, is caused by our proximity to the planet. Nothing to do with our atmosphere or the content of our atmosphere. Nothing about our atmosphere's chemical constitution could augment Earth's temperature one way or another. The only thing that's capable of increasing global temperature on Earth is an increased energy density on Earth. Via the equivalence principle, no substitution. And remember also that we lose hydrogen and helium along with other things to space every year, about 5,500 tons or so, I think, per year, if memory serves. That's our net losses actually to space, which, if anything, of course, should be diminishing the greenhouse effect. So in terms of molecular weight, or in terms of atomic weight of particles lost to space each year, each of which is capable of holding a relative energy density in terms of photons, the energy density of our planet could only be increased by moving it closer to the sun. We're only ever going to receive more photons per unit volume of space if we just get closer to the sun. That is the only way we'll ever receive more heat, i.e. from the sun. Okay, so I hope that answers certain people's questions.